the actual capacity of the Spark. Okay, earlier in the context of the Hadoop and big data kind of things we have seen, and now especially which are all the capabilities of the Spark. Okay, rather than uh, in the glasses of Hadoop ecosystem, in a generic way, in a most common way, how these kind of aspects really helping us. Okay, we'll see those kind of points also. This point is not new for us. This already we have seen. Closely integrated with Hadoop, it can run on and works with Hadoop file formats and storage backends. This point, guys, Spark best known for its capabilities or ability to keep large working data sets in memory between jobs. Suppose job one, job two, job three is there. It is maintaining the switching between job according to the pauses, according to the requirement of the data. This capability allows Spark to outperform the equivalent MR workflow jobs. See, guys, here. This is the most important thing we have to observe. I'm having the MR jobs. Maybe the job got split into three. And in the map reduce, I'm having the tasks related to this job, task one, task two, like that. And this is having task three, task four, five, six, and seven. This is related to the MR jobs. Whereas in terms of Spark jobs, what I can observe is this job turned into the stages again given to the executors. And while running the MapReduce jobs, the problem is every time the job is going to dependent on the Hadoop distributed file system. Whereas in Spark jobs, friends, here the job is split into the stages. The stages are again split into the executors. Okay. So comparatively, these Spark jobs are not at all dependent on the disk. It is going to store in the in-memory computing. So that definitely switching the jobs and as well as fetching the appropriate content is definitely less when compared with the MapReduce jobs. So that point, that is the internal aspect of the third point. Now the fourth point, two styles of applications that benefit greatly from Spark processing model are iterative and as well as the interactive. At this point, this is iterative versus interactive. So here, iterative jobs, as I said, friends, maybe the payroll, or maybe the understanding of the movie rating. If any new movie is there, just I want to float some kind of the SMS polls or any means. Maybe I can open some kind of the chart with the corresponding customers. Okay, so iterative specifies that a repetition actually, which is some sort of repetition. And rarely, if you take the um, consent of the user in between while running the application also, if I am making use of that repetitions as a routine activity, guys. Okay, there is no much interaction of the user or intervention of the user. Just he submits the job, he gives some kind of the inputs. Accordingly, the job is going to return the output. Okay, so that is what how you can understand. Interactive is not like that. So suppose job one is performing some task one. After that, you need to give your consent yes or no, or maybe some other input. Instantly, I'm giving some more input to this particular job. So this is completely driven by the user responses. Okay. For both the iterative and interactive, Spark is best. Okay. As I said earlier, Spark is suitable for batch, iterative, and as well as interactive. So all these kind of the aspects, all these kind of the things, just you can manage with the Spark engine, guys. That is the next one. And of course, these are all not exaggerations, really. Yeah, clearly you can see the way we are submitting the jobs and we are implementing the jobs. That's what I said. It's definitely not heavy coding and heavy things are not at all required. However, today we have seen some of the examples. From tomorrow onwards, just RGD and data frame, so out and out implementations, all these things we are going to talk. Okay, that time you can easily see that how simple the coding is and how good the appropriate running speed and utilization of the memory, all the things you can realize. Next point, the fifth point actually, DAG already we have studied actually. Studied in the sense we have seen because DAG itself is one of the major important component which is contributing for the success of the Spark. So, of course, in the coming session, a complete narration of the after completion of two or three demonstrative examples, implementations, and coding, we'll see this DAG and complete Spark architecture, friends. So you then you can realize that oh, this way we are writing the code, and this way we are running the applications. So internally, these are all the components available, and our code travels like this. So those kind of conventions you can easily observe. So even if you don't need in-memory caching, okay, Spark is very attractive for a couple of other reasons like DAG and user experience. A certain examples are there, guys. Maybe I never bother about my space or memory requirements. My only interest is no matter you take some 2 hours or 3 hours of the time, but outcome must be in a best way. The result must be in a best way. If that is the case, uh, friends here, obviously, what I mean to say is in-memory computing is not only the attraction of the Spark, because some applications are definitely not memory centric. Space they never mind. Only the thing is they want understanding of the data and they want to preserve some kind of the specifications. Okay, in that particular case also, just you can observe guys. These kind of the conventions are very much helpful. Okay, apart from the in-memory computing, DAG and user how he create these jobs, how he submit these jobs, and all the user experience. Okay, that web user interface we have seen related to the Spark, all those kind of things considered. Now, final and last important point is, unlike MapReduce, Spark DAG engine can process arbitrary pipelines of the operators and translate them. Okay, and translate them into a single job for the user. Oh, just the sixth point. Friends. MapReduce jobs, we are having job one, job two, job three, and the corresponding tasks. Okay, here I am having the tasks. Definitely, guys, there is a independency in the tasks while running the MR jobs. But have a look on this, guys. Spark job. So J1, J2, and J3. Here I am having the executor one, executor two, three, and four. Fine. Now there is a concept called pipeline. Very, very useful pipeline. What it refers to? I can make use of E1, E2, and just these jobs internally running, and you can establish a kind of the pipeline. Okay, a connector is some kind of the integration. So maybe I can say the pipeline in this way. Suppose let me give you the scenario. We are making use of the Twitter data. Assume the same example, some research paper we are writing. Okay, so some members, Akhil. Like that, these three guys are writing some article. Now, Praveen posted this thing in Twitter, his Twitter account, and we got some kind of the replies or responses or tweets corresponding to this tweet. Now the pipeline how I can do is I can use the Kafka with Spark streaming, okay, and I can collect the data. Now this thing, after collection of the data, I'm launching some classification technique. Okay, this classification technique is um something like to find out uh, how many tweets are positive, how many are negative. Okay, that means 50 positive, 30 negative, something like that. So definitely I should use the some kind of logistic regression. Okay, yes or no kind of thing. True or false. Maybe like this we can say. Maybe yes or no. Whether our article can be published. My interest is if more number of yes is there, I want to publish the article. If more number of no is there, then I should revise the article because the researchers, the audience, and practitioners they have suggested many points. Maybe we have not scoped those points, and without those points, we are not in a position of influencing the market. Okay, so just we have applied some kind of the classification, and then we got some result, and finally the result will be connected with some measures. Okay, measure in the sense I should define that. No? So my model is good or my model is performing well. So for that, I'm having the measure. So in a way, just we are collecting the data and we are connecting with this to some kind of the processing, maybe some kind of the classification algorithm. And then I got some result. And this result again, I'm applying some metrics. So the entire things can be connected with the help of the pipelines. Actually, they're all independent tasks. Collection of the data, applying of the algorithms, generation of the model. And after this algorithm, friends, we are going to generate the model actually. And as a model, just we are getting some results. And the results can be estimated, measured. Okay, these are all nothing but the pipeline of activities. These pipelines are really helping us to consolidate, to activate the appropriate thing. So pipelines of operators and translate them into a single job. Now our job is just estimation of the tweets and whether those tweets are really helping us. Yes or no kind of whether we have to publish the article or not publish the article or we have to revise the article. So that is how you can classify. This is one of the important observation while talking about the Spark orientation. So, Spark is a cluster management tool or cluster computing framework for large scale data processing. See, it's not even the definition is not even in 3 or 4 lines. In case of the Hadoop, we are having a framework which is combination of the HDFS and MapReduce, those things. But your Apache Spark is a cluster computing basically, which is a framework for large scale data processing and all those things. Now, let me pull some other concepts so that we can discuss some few additional points related to the Spark orientation. Why we need to use this Spark? Because after getting what exactly Spark is and which are all the capabilities of the Spark, the next immediate question is why I need to go with the Spark. So though indirectly we studied Spark is in memory and Spark can be easily integrated with Hadoop, so it can enjoy the benefits of the batch processing. Spark support batch, interactive, and iterative. These things we know actually. Apart from that, okay, which are all other considerations. As one of our friends said, Spark support range of programming languages like Java, it supports Python, R, and Scala. Of course, that is obvious reason why I should venture the computing framework of the Spark. So the another important thing is simple. Spark is pretty simple. Observe here, guys. The balance, the equation is like I want to implement the complex task with simple code. See here. My requirement is to implement the complex task, but I want to achieve that particular thing with the simple code. Okay, so that is how you can observe. And Spark's capabilities are accessible via a set of rich APIs, all designed specifically for interacting quickly and easily with data at a scale. So maybe the constructs are like this: RDD, data frame. Internally, we are having many things, friends. Okay, so those things one by one will talk. Like transformations we're having, actions I'm having, all those aspects. Just we'll see as a next step. Speed of computing. Okay, these 2 points are pretty straightforward. Like support of many programming languages, and Spark is simple in observing the RDD data frames with the simple constructs. You can achieve the complex requirements. Next point is very why industry is adopting this Spark kind of the projects nowadays is Spark is designed for the speed operating both in memory on and on disk. See here, guys. Spark is not against to the usage of the disk. Of course, its basic preference is memory, and of course, it run on top of the disk also. It's run on top of the disk also. So there is one evidence trend because simplicity support we can easily defend. If any member ask, then you can see your show your cluster like it is supporting PySpark, Scala, and R. They can convince. And simple constructs. I have shown you some kind of the code snippets. Just with that, we can easily convince the members, the audience. But how do you prove Spark is speed? So that we are having one project, friends, actually. There is one like Kaggle, how they are putting some kind of the challenges. This is a gray sort challenge, benchmark challenge is there. Processing 100 TB data, 100 terabytes of the data of data stored of solid state drives in just 23 minutes. Just 23 minutes. Guys, 100 TB data. It's not a simple thing, the heavy data. And the previous winner, okay, the winner of that organization earlier Grace Art Challenge was taken up by this Hadoop, and it took around 72 minutes. Okay, three times. Actually, 23 minutes incurred by Spark job. 72 minutes were incurred by Hadoop. Okay, so just you can see this Grace Art okay challenge. So just you can let me see that, friends. 1 minute. Gray sort challenge, what it does, and how it is giving. So let me share the screen, guys. Okay, these things you can make use of the evidential aspects while explaining the topics. So this Gray sort challenge, probably 100 TB data, as in our example. Maybe more than that also. That too in 2014. It's not now. There is some, it must be there. Oh, the article removed actually. No problem. Spark itself has given because I thought of taking some other evidence because obviously Spark is talking in terms of this thing. It is, of course, it depends like anything. It took some 23 minutes. The earlier record 72 minutes by Hadoop. Okay, it is having 2100 nodes. It is, of course, elastic computing. Now, generally, guys, the people who are having the background of AWS or Azure, they can observe this what is large and medium or smaller machines. Even while establishing a kind of the cluster for us for the projects, um, what we'll do is we'll make use of the appropriate convention. Okay, so just I am pasting this into the chat window as a task, just you can see, friends, what exactly the challenge is and how we are making use of that convention and what exactly the background of that. Mm, Here, Databricks, of course, I will pull um, some other aspects to you guys, not only this Jupyter Hub, because Databricks is something like which is going to rule the world very soon. Okay, especially who are the inventors of this Spark. Of course, Apache is a that they provide some sort of open source and all these umbrella kind of activities. But officially, the proprietary kind of thing still with Databricks only. This is a community edition. There exists, if you refer the Databricks kind of the orientation, there are certain aspects, excellent uh, platform guys for learning Spark and to clear the certification. Okay, many things are there, data lake, all these kind of the conventions, all that all. Okay, all that freeware. And just to see this article, what it says, data size, how much, and Spark record and how much time it has taken, elapsed time in case of Hadoop, Spark record 23 minutes. And of course, friends, in Spark, rather than using that one, some other versions are also there, which are quite time consuming. Okay, number of nodes, 2100, and it is only 206. With the 206 machines only, it can able to reduce the time to 23 minutes. All physical machines, actually, around 50,000 cores, 50,400 physical cores were there, but these are virtual cores, 6592. Okay, our comparison is only these two guys, just we are making use of. So cluster disk throughput, if you observe in all the parameters, Spark records very less scores. I mean, in a positive way, less score in the sense it is using very less resources. Yeah, let me put in that way. Uh, these are all normal and 1.42 terabytes sort rate. Because sorting itself is one of the important phase in Hadoop, and we cannot avoid that because in Spark it's not a default kind of thing. There is no such kind of map phase, reduce phase, sort phase, and input split phase. And here the convention is completely different. Probably in the Spark architecture, we are going to see the distinction between the way how the map reduce is executing and how Spark is executing. And start rate, however, according to the requirement, it is going to perform. Uh, the additional information, just if you want to get, so just you can make use of these examples and all these things, which are really good articles. Friends. Databricks is proprietary for Spark. Some or other way you need to get into these things. Now, one more point I want to share with you. The people who are not having, uh, who are not installed Hadoop or any cluster, whatever, whichever I have shared. But even they, if they want to establish some sort of, some sort of Spark-based programming, don't worry. Just we're having the Databricks edition. Friends. Let me give you that. So just we are having this thing get started for free. The Databricks Community Edition will be there, and it is asking us which cloud provider you want. Okay, maybe Microsoft Azure, Cloud Platform, GCP or Amazon, whichever. Okay, whichever. Just I'm selecting this Azure. No difference, friends. Only just it is a kind of community edition where you can make use of your convention of using the data. Okay, so just it is taking some first time. Otherwise, I'm having this thing from the actual. I created Databricks. 1 minute. Yes, let me show you that thing. Otherwise, it is taking some time. No? Okay, just a second. Which is a hand difference. Now, immediately you can uh, create your Databricks community edition just to sign in. It is providing us a platform actually, a community platform. Already I have executed for the Databricks, data engineering and machine learning guys have given this. And the most important thing is, see, it is pretty similar to our Jupyter Notebook and Jupyter Hub kind of thing, the cells and all. Most importantly, you observe here, we are having Python support, SQL support, Scala support, and R support. Okay, all these things. And by default, of course, it is also going through Python, and I can change it to either Scala, SQL Scala, and as well as the R programming. And most importantly, if I want to run this thing, just I can run cell, but it gives some error frames because there is no cluster actually. There is no cluster. Now what I can do is just I can create a cluster. See, it is creating notebook. It is allowing us to create a notebook table or cluster. Cluster, what it says is as Spark, Spark is a cluster computing framework. Okay, the cluster name, what I'm giving is Big Data Tools 1. Uh, and moreover, guys, it is providing some kind of the one driver with 15.3 GB memory and 2 crores. Okay, and one Databricks unit. Okay, this is the combination of this one. So a Databricks unit is a processing capability per hour. Okay, this is having a kind of the support for it. It is a freeware, friends, community edition for the learning purpose. And moreover, the Databricks runtime environment. It is having many kind of the aspects. Always go with the stable, long-time evolution, long-term support. These are all maybe, guys, these things are, I can say, these are all some beta versions and all. And if you want to venture that, simply select that. Okay, whatever the requirement you want, you can do that. And moreover, here I'm having the standard or ML. These things are standard as we are interested to initially work with RDD and data frames, and later point of time you can ML orientation. Okay, like machine learning library, MLlib and all, like that it is supporting because there is a separate package and there is a separate support for machine learning kind of the activities. As I said, there are classifications, regression, such kind of the algorithmic aspects are there. Now it is simple to use the standard and click on this thing. Okay, and don't touch anything, let it be, whatever the things. And here, all these conventions I can see, and just to give the create cluster. Because if I want to run any kind of the application, I should run that particular application on top of the cluster. So just to create a cluster. It will take some time frame, definitely. So while making use of this cluster management, now if I want to run that, just I should make use of integration of this cluster. Or let it be. Or let it be running. And meantime, we'll discuss some other points. Okay, let me access that. Or yeah, one more option I can give you. What is the distinction between the map reduce and as well as the Spark. By this time, we got everything in our hand. How Spark is winning the race. Now, if you observe a clear-cut distinction, because before launching of that cluster, I don't want to miss out the time. Uh, so for that purpose, just I am pulling one more topic. So in between, after launching of that cluster, I will show you how to establish the connection between your Jupyter notebook and as well as the cluster, so that you can start preparing or start practicing whatever the code I am supplying after completion of the sessions. Now observe here, guys. So in case of the map reduce, the typical map reduce reads the map reduce reads the data, and then again MapReduce temporary result I'll write to the Hadoop distributed file system. Again, it is going to read the data for the shuffle or sorting, and finally it is going to write the data. So total four IO activities. Okay, so for each and every IO activity, it needs some unit of the time. So 4 units of the time incurred without doing anything, friends. Just it is only reading or writing. Job is different actually. After reading the data, MapReduce is going to use the data to run the application. But here, it's not doing anything actually. Reading and writing in the sense it is, of course, required, but definitely these 4 units are not comes under the scope of the job execution, above and beyond that. Okay. Now this thing you see, though I am using the Hadoop distributed file system to run the Spark, initially your data is placed into the memory, main memory, and it is performing some operation, maybe some transformation or whatever. Transformation is not going to execution because it is lazy evaluation, and it continues the data. And whenever there is a need of action, there is a difference between transformation and as well as action. Transformation is lazy. Action, okay, immediately execute. This action will perform the activity actually. I will show which are all the transformations and actions supported by the Spark. Probably tomorrow our discussion is RDD creation and usage of the RDD and all these introduction to the transformations, actions, and understanding of the Spark architecture. Okay, all these things because now we are equipped with some contextual knowledge of our Spark. Now we need to consolidate everything into a architecture and in the implementation perspective. And maybe suppose if I want to submit a job, as said, just I will be having this Spark submit. My master is add, and I'm having my deploy mode. I want to use the cluster deployment mode, cluster, and here I can mention the corresponding file. And of course, in WCPY, what could be the whatever the logic I'm having, there I need to specify my input file. I can specify my output file. Now, according to this context, my input file is in HDFS, and I am guiding through this program. I am guiding that output also to HDFS. Okay. To notify this, 1 minute, friends. I'm having something for you uh, where I can show you the coding also. Hmm, yes, got it. Because that code really helps you to understand what I'm saying. Hmm, just a minute. Pick the data, okay, and paste it here. As you can see here. So in the OneNote, just I collected the appropriate information. How I am writing the code in Spark actually. So leave that things, friends. Spark context and all I will be discussing soon. Here, this point you observe, I am picking the data from Hadoop distributed file system. So my input is from HDFS, and I am applying some logic And finally, I'm saving this file in Spark output 100. This also I'm saving in HDFS. Okay. So here, whatever the input I'm talking, just I'm saying that this is my input. Read the data from text file. Or just I'm fetching the data. And after that, save the counts to the output. In either way, just I'm using my input file from the HDFS and output from the HDFS. But the logic and all, they are never touched with the HDFS. So if I'm moving back to this example, the same kind of example, whatever I have taken, these 4 units are required. These only 2 units are required. So that means the IO is not going to touch base on the disk. And you pretty know that your disk accessing is pretty expensive when compared with the memory access. Maybe even Spark is dependent on the caching. We are having separate topic for that, persistent and cache. And related to this random access memory, definitely that RAM access is pretty speed compared with the HDFS access, drive access. Suppose I'm having hard disk and I should verify and get the thing. But whereas within the RAM, if my program is having the data, it need not go and request for the disk access. Okay, so this is how the distinction. And let us go back to our cluster. 1 minute. Friends. This yeah, cluster has been established actually. Uh, see, so the cluster has been established. Big data tools one, and what you can do is just you can resend some kind of functionality I'm having. Maybe I can take the Spark session. Click on this. Okay, initial code friend actually. Now what I can do is just I can give a try on run cell. It may ask me to add the cluster. Yes, big data tool just now created. Attach and run. Simple. You need not do any configurations at all. Attach and run. Obviously, it is running. So it is providing the information like we have seen in our cluster also. Just we have seen Spark. If I am giving the thing, and you could have observed this point also, friends. I did not mention any import statements. Import I have not given, and I have not created any app. Simple in a simplest way without defining anything. Our Databricks providing or observing this object directly, you can make use of that one. So Spark session, Spark context, just it is giving the advantage. Now this Spark user interface, already web interface we have seen the same kind of the thing. If you click on this, but it is a community edition, friends. So you may not get the entire aspects. Um, Similar to our AWS Cloudera distribution, here also we're having some kind of event timeline and all these kind of things, stages info, okay, executors everywhere, friends. No matter whether you are working with AWS based Databricks cluster or Azure or GCP or maybe your Cloudera, whichever, the same kind of the things. Okay, so executors, environment, all these kind of the aspects. Okay, executors page, how the job is executing and all. Okay, so with this, just you can make use of this thing, friends. No need without installing anything. Directly, you can make use of this particular Databricks. But only the thing is, you need to have your mail ID, maybe company mail ID, or else you can use your personal Gmail ID or Outlook or whichever. Okay, whichever you want, you can make use of that convention. And programming wise, okay, see here the constructs are pretty simple. In Scala, Scala also Spark remains same. Just this is in a simplest way. Either I can select this way. I mean, earlier, we are having these many things na, that way, or else explicitly I can mention percentage. So obviously, the context of cell turned into Spark to Scala. Okay. So moreover, guys, the programming Scala and Spark, PySpark are very near, except in a few kind of the things. You can make use of that benefit, and of course, majority of 98 percentage, not majority, 98 percentage of the projects are using PySpark, and 1% or 1.2% we are using Java. Remaining 0.2% Scala. Maybe is a big surprise for you. And earlier, first time while I have seen that research article on the usage of PySpark versus Scala versus Java, even I also felt the same thing. Okay, so with this, just we can stop here logically. Um, all the key takeaways, okay, just many a times we have referred. So what I will do is in the next session, just I will be giving you the recap of whatever the topics we have covered. And my strong recommendation is just you register for this Databricks. How do you go for this Databricks is just we need to type the appropriate Databricks. Uh, I already have given this thing, friends. Apache Spark Databricks thing. Just to click on that. So try Databricks for free. Okay, then you need to. It may ask you whether you need to select AWS or Azure or whichever. Accordingly, you can view that convention. Okay, so while making use of this cluster, moreover, friends, after 35 minutes or something like that, your cluster is disabled actually. Now, again, you have to create many clusters you can create, but without cluster, you cannot run your application. Okay, so get started. It asks for you some email ID. Accordingly, you can give that. Okay, take me to Azure Database, free trial, start free. Maybe a little modifications they have done. Earlier, it's not like that. Okay, so just to spend some time and sign in and use your work, Databricks unit channel. They say 14 days only, but don't worry, you can extend anything. Okay, so that's all, guys, for today's session. And thank you for your support of conducting these sessions. 3 hours teaching is different. 3 hours listening and staying in the call is even more difficult. But you are all doing that. Okay, so I appreciate your efforts. So thank you all. Bye.
Thank you, sir.
Thank you, sir.
Thank
Thank you,
thank
Pawan.
you all.
Thank you, sir.
Yeah,
Thank you,
thank you.
sir.